All right, hey everyone. Today this video is going to go over the lesson reading data into R, or focusing on how to get your spreadsheets and data into R. So this is sort of the place to start, right? Most of us are coming to this class imagining that we will one day have data, or maybe you already have data that you want to read into R so that you can start analyzing. And the first question that we'll address today is really how to get it into R and how to inspect it a little bit using some base R functions. So we can go ahead, we're on our RStudio screen open already, and we can go ahead and open a new script for the sake of this class, and we can go ahead and maybe even save it already. So to get into the habit of sort of storing your code as code and as notes, and get into the habit of some naming conventions. So if I save it, you'll see my computer sort of already populated it. Well, okay, if we start in our R Davis class project, I've already created a scripts folder. So this is something we talked about last week. You hopefully will have already created yourself a scripts folder as well. And you can get into the habit of some kind of naming convention. Maybe in this case, it will be week 3 notes. And I generally recommend naming things both in R and R files separated by only underscores and not spaces, as it makes readability of files easier later. So we can go ahead and save that and get started. So the goals for this lesson are really to practice using the read.csv function to read in data, and to explore and subset data frames. And later on, we're going to talk a little bit about packages and this concept of base R versus the tidyverse in another lesson. So you'll notice I annotate my code a lot. Remember, we can annotate or take notes inside an R script by starting lines with a hashtag. One hashtag is good, 2 hashtag I sort of use for my own personal idea, like bullet points or notes. But you can kind of get into the habit of this for taking notes yourself while you code. And it's really kind of a personal choice. But so anyway, step 1, we want to talk about getting your data into R. And one of the reasons we started the first 2 classes really setting up this whole project management framework and talking about folders and talking about files is that it can be really frustrating to try to start this process and not know literally where to find the data that you want to read in, or how to navigate to it in RStudio. And so we're going to tackle that a little bit. But first, we're going to want to read in our data in a way that assigns our data to an object. We talked about this the other week. R wants to see us assign and name things as objects, and that's how it operates. So there are lots of naming conventions. I tend to call most of my data DF, short for data frame, but for most of our exercises, we'll refer to them as surveys, but this is really a choice. We'll use our assignment arrow to assign this object based on the function that we put on the right-hand side of the arrow. And so this function is going to be read.csv. You'll see that R already prompts me. And inside read.csv, we want to use the quotation marks because we're looking into a file path, and file paths are usually navigated to through quotation marks. And because, as I've said previously, we live in our R projects, our file path begins knowing and more or less looking at this same set of files that RStudio makes available to us in the bottom right-hand corner. And so all we need to do is type in data /, and then we can use our tab button to know that we're on the right track. And this tab button should show us the data that we have already pre-stored into this folder for you for the class. And so you can see our options here: portal data joined, survey data spreadsheet, and tail length. We are going to be working with the portal data joined. So you can either click on that or keep typing, and it will eventually become your only option. So porta_data_joined.csv. And we're going to execute this line with Command or Control Enter. And we can now see that surveys has been stored into our global environment as an object. This global environment does tell us a little bit about the data. And so we're gonna look to some functions in R that can tell us this information and more. So let's see, we're going to be inspecting the data. Just this. So we're going to sort of ask ourselves, what are the dimensions of the data? And some pretty intuitive functions for looking at dimensions are n row, so the number of rows, parentheses, and inside this, all we have to do is specify, I want the number of rows of surveys inside the parentheses. And it will spit out and tell me 34,786, as it also reads up here in the global environment. We can also use ncol for n column. Also, again, just using surveys as the argument inside the function. And we can see that there's 13. I also forgot to note as a reminder, so looking at what kind of data is surveys. Tyler talked a bit about all sorts of different data types last week, and you'll sort of get into the groove of understanding what the different data types are in R and how to use them and what they mean. But a good sort of base inspection is to use the function of class. So what class is the object surveys? So class parentheses surveys, and we can see that this is indeed a data frame. If this said a list, we would then, as we learned last week, maybe treat this a little bit differently. We can also look at sort of the top or bottom entries into this data frame. So it's a good way of sort of glancing at your data. And this can be done through the function head. So kind of saying, I want to look at the top of the data. So using the function head surveys, we see that in our console, we can now read maybe not all 13, 1, 2, 3, 4, 5, 6, 7, 8. Okay, all 13 columns and just the first 6 observations. That's just what the function head is built in to give us. So you can sort of get a glance at the data. And similarly, the function tail with surveys inside it will give us the bottom 6. So this is just kind of a good way to look at the top and the bottom of the data. If you want to look at the data, I mean, let's say in its entirety, I do use this a lot, just because I think I've sort of trained to think of it as an Excel spreadsheet. I want to see it in that form. And there are 2 ways to do this. One is that you can actually go up into the global environment and click on the name of the object itself. So if you click on surveys, it will automatically open up the survey spreadsheet in another tab right next to your scripts. Or if you can do this through code by using the function view with a capital V. I think it's pretty rare that there are capitals in our functions, and this is, for me, one of the few ones that I know really relies on the capital V. So capital V view with surveys. Here we have this automatic opening of surveys into this other tab, and it will usually show you 50 columns at a time if there are more than 50 columns. But you can scroll through it maybe in a way that you're used to navigating an Excel spreadsheet. And a little bit more about the data itself. So again, we talked a little bit about data types, and we might be asking ourselves, what are these 13 columns? What kind of data types are they? And I think 2 good functions for this. This one that we explored last week is the str function, which I think stands for structure, so the internal structure of an object. And so if we look at the structure of surveys, we get what initially kind of looks like a weird output, but you'll get used to all the information that it can give you out here in the console. So first, it tells you that this entire object of surveys is a data frame with these dimensions, and then below it, there are all these dollar signs, which are going to indicate the column. So you have 13 different columns, 13 different dollar signs, the name of these columns. And then after the colon, you'll see things like int or cur, and there are a couple more that these could possibly be. But what these are abbreviations of different data types. So record ID as the first column, for instance, int is an integer, and then it will give you the first however many integers or rows in this column, and so on and so forth. You can see that, importantly, this switches over in the 6th column, species ID. It's the first character we see. So last week we talked a little bit about strings, and I generally think of strings as character vectors. So that means that the species ID column in the data frame of surveys is a vector of characters. And remember that characters are just not numbers. So in this case, there are a lot of cues that tell us this. Each of these observations is put in quotation marks, and quotation marks are a pretty good giveaway that this is not a number. And inside those quotation marks, we see NL, which you imagine is a species ID, an abbreviation for something. And you see something similar in the next column of sex. It's another character, and you see some capital M's, some non-filled quotations. But so these are two big different data types that will often come up in our data that we'll be revisiting. In a somewhat similar way, the summary function does something similar to structure. It spits out each of our columns again, although I guess it's actually not that similar. Instead of telling us the types of data or the structure of the data, it actually summarizes each column. So for each of the integers, it gives you the mean, quartiles, median, mean, and max. But you'll notice that for the character vectors, so like species ID, it will not give us these same summary statistics because it doesn't really make any sense to give summary statistics like a mean for a character vector. And in fact, it's impossible. So it just tells us how many there are. So the length and the class and the mode, pretty much otherwise saying, I don't know how to give you the mean and median, et cetera, of these variables. Okay, let's talk a little bit about indexing. So last week, we talked about how to index a vector, which was using square brackets to subset a certain something out of a vector. And we're going to apply that same concept to data frames. So generally, when I think about indexing in a data frame, inside the brackets, it goes bracket, row, comma, column. So you more or less need to remember that row comes first, and then after a comma is a column. And this is one of the ways that we signal R how to pull out the pieces of the data frame that we want. So let's look at an example and correct our spelling of brackets. But okay, so we have our surveys object. And remember, if I just command or enter this, then we get this long output, which isn't very readable. But let's say I just want to look at the first row and first column of surveys. I will tell R that I want the first row as my first argument, comma, and the first column by entering a 1 into the second argument. And if I execute this command, I get just the value 1 because our first column is record ID, and the first record ID in our first row is 1. And this can be extended pretty naturally. You might imagine you can look for the first row, the sixth column, which is the species NL. You don't always have to include an argument, so you can just do a comma and then 6. And this will actually give you everything in the sixth column. So we did not specify a row number. We just skipped over a specification. We did comma and 6. And so we get this is our vector of species ID. In a similar way, if you don't include a first argument or a comma, then you still get just a character, you still get a vector, and it's a bit ugly to wade through, but you'll notice that its output is actually different than the one above. So the one above didn't really allow for any space, doesn't really look like a column, because this notation or this way of indexing pulls out a vector. So I can write this, extracts a vector. Whereas this way of extraction, I think, maintains the data frame. And I think I'm saying that right, but one way to check my work here is to ask R. So I think that first extraction is a vector, and so I can actually ask it class surveys and then type this same bracket comma 6. And I misplaced or did not include an S, so it tells me that that object is not found, so I have to correct my typo. And it tells me that the class of survey 6 is just a character, so it's looking, well, this actually might not be helpful. But let's see. So this is a data frame, but what is class of surveys 6, bracket 6 with no comma? And it is a data frame. We'll see that I actually checked my work on pause. So different kinds of subsetting can yield different kinds of object outputs is the point. There are a few different nuances on sort of some special signs for subsetting, which I will, it's hard, but the colon, right, helps kind of present a range. That's what I'm looking for. And negative sign subtracts. So what does this mean? Surveys. Let's say that I want to look at rows 1 through 6. So I do bracket 1 through 6, comma, and this shows me, similar to head, it shows me the first 6. So I don't need to specify 1, 2, 3, 4, 5, 6. And let's say, for example, I actually want to exclude the first 6 rows. We'll note, I'll show something that doesn't work, which I think is a lot of people's intuition to use, which is negative 1 through 6, comma. And you get this error in XJI, only zeros, maybe mixed with negative subscripts. I'm still not ready to unpack that one quite yet. And that's true for some errors, but we can say that generally we'll be receptive if you want to take away a whole set of rows or columns. In any other case, if you put them in parentheses, that's going to do the trick. And you'll notice that if we look at our output, we start with row number 7. So if you want to subtract something that is more than one row or column, then you can put it in parentheses. However, if it was just one, if you said, I just want to exclude row 1, R typically doesn't have any problem with that. We start with record 2, as you can see in the console output. Okay, and the last little bit here is going to be subsetting with column name. So there are a number of ways we can subset. Up until now, we've really been using numbers. You have to know exactly what row and or column number you want. But realistically, it's much more common that you know the name of the column you want, or you know the name of the row or something along that line. And so we'll talk a little bit about that, which is the logic is still similar within our surveys object, and then the bracket. You can specify in quotation marks here because column names are not objects in this case. In quotation marks, you can specify a certain column name. So species underscore ID, I know is 1. And you can see that I've subsetted just that column. It's helpful to know actually this function as well, call names as an abbreviation for column names, because we may not even remember all of our column names, but this function will spit out all of the names of your columns so that you can refer to them pretty quickly. So we looked at just calling species ID in quotation marks and brackets with no commas. You'll notice that we can do this a few other ways. We can still do a comma and then species ID in quotation marks. But again, notice the difference here. This approach spit out a vector, so it didn't come out in a long column. So output. Data frame. Right. And one last way of subsetting that might, after all of this teaching, be the preferred way of subsetting in the future. At least for me, and it will come up a lot more in other things that we do throughout the class, is using the $sign as a subsetting form. So if you type in your object, if you type in the object of a data frame, followed by the $sign, this will auto prompt our studio, at least, to give you all of the names of the columns that exist in that data frame, so that you can sort of go through and click it, just like we did in our file paths. Or of course you can continue typing. So if I want species ID, we're getting close, and I can really even tab down and arrow down and tab down to autocomplete and then execute it. But notice again, this gives us a vector because we are not in a long column. But these are kind of the core ways that you can be subsetting your data frames, particularly using the base R language. And in the next quick video, we're going to switch over to talking about another kind of language that we will actually be using for the majority of the class.